Assalamualaikum warahmatullahi wabarakatuh. So in this video, we are going to present the topic of our choice, which is oscillators. The group member of our group are me myself, Haikal, Shauki, Fidaus, Amin and Fakrul Raza. For the first part of this video, I am going to explain about the definition of oscillators. Oscillators is an electronic device and a circuit to generate alternating voltage of desired frequency and amplitude. It generates sinusoidal or non-sinusoidal waveform from very low frequency to very high frequency. It also converts DC energy to AC voltage. Oscillator circuit is an amplifier that provides itself through feedback with an input signal. It is a non-rotating device for producing alternating current. The output frequency is determined by characteristics of the device. Lastly, oscillator is used to generate given waveform of a constant peak amplitude and frequency. Next is the basic requirement of an oscillator circuit. From the figure, we can see the basic circuit of oscillator. And the basic requirement are: first, amplification is required to provide the necessary gain for the signal. Second, sufficient regenerative feedback is required to sustain oscillation. And third, a frequency determining device is needed to maintain the desired output frequency. Next, I am going to pass this presentation to my fellow members. Thank you.
There are many types of oscillators, but can broadly be classified into two main categories, which are harmonic oscillators and relaxation oscillators. In a harmonic oscillator, also known as linear oscillators, the energy flow is always from the active component to the passive component, and the frequency of oscillation is decided by the feedback path. Whereas in the relaxation oscillators, the energy is exchanged between the active and the passive component, and the frequency of oscillation is determined by the charging and discharging time constant involved in the process. Further, harmonic oscillators produce low disordered sine wave outputs, while the relaxation oscillators generate non-sinusoidal, which is sawtooth, triangular, or square waveform. Oscillators also can be classified into various types depending on the parameter considered. These classification types have been given below. There are classifications based on the feedback mechanism, such as positive feedback oscillators and negative feedback oscillators. Classification based on the shape of the output waveform, like sine wave oscillators, square or rectangular wave oscillators, and swept oscillators. They are classification based on the frequency of the output signal. For example, low frequency oscillators, audio oscillators, radio frequency oscillators, high frequency oscillators, very high frequency oscillators, and ultra high frequency oscillators. They are also have classification based on the natures of the frequency of the output waveform, like fixed frequency oscillators and variable or tunable frequency oscillators. And lastly, classification based on the type of the frequency control used. For example, RC oscillators, LC oscillators, and crystal oscillators, which
Hi, Assalamualaikum warahmatullahi wabarakatuh. So first, let me introduce myself. My name is Muhammad Fakrul bin Zukiman. So today I will present about the factors affecting the stability of oscillator. As we know, the frequency stability of an oscillator is a measure of its ability to maintain a constant frequency over a long time interval. However, it has been found if an oscillator is set at a particular frequency, it does not maintain it for a long period. So here is example of stable frequency and unstable frequency. There is a change of graph form. The cause of change in oscillation frequency or the factor affecting the stability of oscillation is given as under. The first one is operating point. Here is example of the graph of transistor. The Q point is shown as the operating point. The operating point of the active device, such as bipolar transistor, is selected in such a way that its operation is non-linear region. The change value of device parameter which in turn affects the frequency stability of the oscillator. The next one is circuit component. The value of circuit component such as the resistor, inductors, capacitors and capacitors change with the variation in temperature. So here we can see the temperature will increase and the resistance also increase. Since the change takes place slowly, they also cause a drift in oscillator frequency. The next factor is supply voltage. The change in DC supply voltage applied to the active device shift the oscillator frequency. This problem can be avoided by using a highly regulated power supply. The next factor is the output load. A change in the output load may cause a change in the Q factor of the tank circuit, hereby causing a change in oscillator output frequency. The next factor is inter-element capacitance. Any change in the inter-element capacitance of a transistor, particularly collector to emitter capacitance, cause change in the oscillator frequency and thus affects the frequency stability. The last factor is stray capacitance. The stray capacitance also affect the frequency stability of an oscillator. The effect of change in inter-element capacitance can be neutralized by putting an additional capacitor across the corresponding element. However, it is difficult to avoid the effect of stray capacitance.
Oscillator circuits are commonly used in electrical and electronic instruments. These are some of the crucial advantages of an oscillator circuit, which makes it suitable for application as a power source in AC circuit. First and foremost, the oscillators are cheap in cost, which makes them economical, so it is easily affordable and accessible for the industry. Second, oscillator circuits are also portable. The oscillator uses DC source to convert the unidirectional current into the bidirectional current. Due to the usage of DC source, it does not require any moving component to generate energy. Thus, it makes it less bulky and more portable. Furthermore, an oscillator has low noise. As oscillators do not use any moving part for conversion of energy, thus it makes less noise during operation and provide more convenient atmosphere. Last but not least is varying frequencies. The frequency of oscillation can be modified by the appropriate usage of DC source and its magnitude. Therefore, the oscillators are available with wide range of frequency. So, with different type of frequency, we could get a different type of oscillators.
Assalamualaikum warahmatullahi wabarakatuh. So now I will talk about the application of oscillator. As we know, there is a lot of type of oscillator like linear oscillator and recession oscillator. Oscillators are a cheap and easy way to generate specific frequency of a signal.
For example, an RC oscillator is used to generate a low-frequency signal. An LC oscillator is used to generate a high-frequency signal, and an OPM-based oscillator is used to generate a stable frequency. The frequency of oscillation can be varied by varying the component value with potentiometer arrangement. Here is some common application of oscillator. First, quad watches, which is used a crystal oscillator. Second, used in various audio system and video system. Also used in various radio, TV, and other communication devices. It also used in a computer, metal detector, stun gun, inverter, ultrasonic, and radio frequency application. It also used to generate clock pulses for microprocessor and microcontroller. Used in alarm and buses. Used to operate decorative light, for example dancing light. Here is some of our reference. That's all from us. Thank you. Share. Terima kasih.